Hello future engineers, subscribers, viewers, and students. Here is a video in dynamics which is new in my playlist. So I hope that as I discuss the principles, you will be able to absorb everything that will be discussed here so that you will be prepared in answering questions to problems related to dynamics, particularly rectilinear motion. So let's consider a particle, which is a car here, starting with position SO. This is the starting point, this is the origin, but this particle, the car, starts with SO, position SO from the origin. So this is the path, and the car travels as shown. So let's plot the position versus time. So take note, S is not distance, but the other position of the car, the particle, with respect to time. So after a time t, this is now the position of the car from the origin, and we'll call that S as shown in the figure. So between two periods of time, let's say t sub 1 and t sub 2, the positions should be S1 and S2 respectively. So let us say this is the path. This is the plot of the curve S versus time. Then take note that the car begins with position SO. So this is SO from the origin, and after a time t, the position of the car would be S. And let's consider two periods of time, let's say t sub 1 and t sub 2, and the corresponding position of the car would be S1 and S2. This is delta t, which is t sub 2 minus t sub 1, while this is delta S, which is S2 minus S1, as shown. So the average velocity is the slope of the second line joining these 2 points here, and that is delta S or S2 minus S1 all over T2 minus T1. So that's the definition of average velocity, which is the slope of the second line between these 2 points on the curve S versus time. And this is also equal to delta S over delta T. And the limit of this ratio as delta T approaches 0 from calculus is the derivative of S with respect to time, and this is now interpreted as the instantaneous velocity or simply velocity. So velocity, limit of delta S over delta T as delta T approaches 0 is ds dt. So that's the definition of velocity, the derivative of position S with respect to time, and let's call that equation 1. This is the first differential equation of motion in kinematics. Likewise, if we differentiate v with respect to time, that's the acceleration, and that's the derivative of ds dt. So acceleration, derivative of v with respect to time, second derivative of s with respect to time. So acceleration is dv dt. So that's the derivative with respect to time of v, which is ds dt. Therefore, acceleration is dv dt, second derivative of s with respect to time. Call that equation 2. That's the second differential equation of motion, rectilinear motion. Then from equation 1, if we solve for differential time, it is ds over v, and from equation 2, if we solve for differential time, it is dv over a. So dt equals ds over v from equation 1, and from equation 2, dt is dv over a. Then we equate these two equations, ds over v equals dv over a. Then we can form another equation of differential equations of rectilinear motion, a ds equals v dv. And let's call that equation 3, the third differential equations of motion in kinematics. Then we consider the situation where the acceleration is constant so that we can develop or derive formulas for rectilinear motion and constant acceleration. So use equations 1, 2, and 3 for situations where the acceleration is changing or not constant. Then specifically when the acceleration is constant, so we begin with equation 2 that dv is a dt, then integrating dv with limits vo to v, and we put a before the integral sign. Integral of dt limits would be 0 to t. So integral from vo to v of dv equals a integral from 0 to t of dt. Integral of dv is v, so with limits vo to v, so that's v minus vo, and the integral of dt of course is t, so the right side is at. So v minus v from vo to v equals a times quantity t minus 0, so this is v minus vo equals at. Therefore we can form the first equation in rectilinear motion with constant acceleration. Final velocity is equal to vo plus at, or the instantaneous velocity is equal to vo plus at. Call that equation 2.1 because it comes from equation 2. Then from equation 1, we have ds equals v dt, and we replace v by this derived formula vo plus at. So vo is constant, a is constant, integrating ds with limits so to s for ds, and for dt 0 to t. So the integral of ds is s, so with limits so to s, so this is s minus so. Then the right side, the integral would be vot plus 1/2 at square. So s minus so equals vot plus 1/2 at square. So we can develop another formula for the case where acceleration is constant. S equals so plus vot plus 1/2 at square. So call that equation 1.1 because it comes from equation 1. Then we proceed to the third equation here, ads equals vdv, integrating ds s from so to s, integral of vdv from vo to v. So ads equals vdv, so a integral of ds from so to s equals integral of vdv from vo to v. So this is a times s minus so. The right side is v squared over 2 from vo to v. So a times s minus so equals v squared over 2 from vo to v. So cross multiply, we have 2 times a quantity s minus so equals v squared minus vo squared. So the third equation, we'll call this 3.1, would be final velocity square equals vo square plus 2a quantity s minus so. So call this equation 3.1. So from here, this is the instantaneous acceleration. The average acceleration therefore is delta v over delta t. Specifically, delta v over delta t is v sub 2 minus v sub 1 over t sub 2 minus t sub 1. So average acceleration equals v sub 2 minus v sub 1 over t sub 2 minus t sub 1, or simply delta v over delta t. Then for the average speed is a scalar quantity. It is equal to the actual distance traveled which is always positive because that's distance, divided by change in time, which is t2 minus t1. So average speed, capital S sub average equals actual distance traveled divided by t sub 2 minus t sub 1. Then let me demonstrate to you how to compute the change in displacement, which is just the change in position, final position minus initial position, and the actual distance traveled by the particle. So for instance, so we have here a path, and let us say that's the origin, and the particle begins with this position here, which is to the left of the origin, so the position would be negative, so let us say negative 10 units. Then the particle moves as shown in the figure, and it moves to this extreme right position, and this is, let us say, the final position, and the coordinates or the positions would be, let us say, 36 units, and the final position would be 20 units to the right of the origin. So the final position of the particle, considering these time periods from this time, let us say this may be 0, and this time here, this may be any value of t. So since change in displacement is final position minus initial position, the final position is 20, positive 20, and the initial position is negative 10. So change in displacement delta S would be 20 minus negative 10, and that's 30 units. So that's the change in displacement. Whereas the actual distance traveled is the total length of the path actually traveled or traced by the particle. So it would be 10 units. So from this position to the origin, that's 10 units. Then it moves to this position here, 36, so plus 36. Then it goes back to this final position to 20. And this distance is 36 minus 20, or 16 units. So therefore, the actual distance traveled by the particle is 10 plus 36 plus quantity 36 minus 20, or plus 16. So it is 10 plus 36 plus quantity 36 minus 20. So therefore, that's 10 plus 36, 46 units plus 16 units, 46 plus 16. So the actual distance traveled by the particle is 62 units. So that's the demonstration. I hope that it is clear that the distance is always positive, and it is simply the length of the actual path traced by the particle or moved by the particle. Whereas the change in displacement is simply final position, in this case 20, minus initial position negative 10. So 20 minus quantity negative 10 is 30 meters. Then in general, the change in displacement is not equal to the distance traveled by the particle, because the change in displacement may be negative, whereas actual distance traveled by the particle is always positive. There are situations, however, where the change in displacement may be equal to the distance traveled. So for instance, if the particle begins with the origin and it moves rightward, its movement is purely rightward. So let us say from the origin, it moves to the right to this position 36. So the change in displacement is 36 minus 0, so 36 units, and that's positive. The distance traveled is also 36, because from 0 to 36, it's 36. So that's the situation where the change in displacement may be or is equal to the actual distance traveled if the particle moves to the right and it begins with the origin and its movement is purely rightward. it has not situation where it tends to go back. So rightward movement, purely rightward movement only. So that's the case where the change in displacement may be equal to the actual distance traveled. We then proceed so this is the actual distance traveled. So let's have this first example to demonstrate the concepts that have just presented. The motion of a particle is defined by the relation x equals 3t cubed minus 6t squared minus 12t plus 5, where x and t are expressed in meters and seconds respectively. So determine letter A when the velocity is 0, the position when t is 4 seconds, so the particle is moving along the horizontal path because this is x. However, the velocity and accelerations would not be constant. The position when t is 4, c the acceleration when t is 4 seconds, d the total distance traveled after 4 seconds, so beginning with 0 second, the average velocity during the time interval 1 to 4, the average speed during the time interval 1 to 4, and g the average acceleration during the time interval 1 to 4. So first, for the velocity, the expression for velocity is, in particular, v sub x is the derivative of x with respect to time. So remember, velocity is derivative of position with respect to time, ds dt in general, but in this problem, dx dt, and it is v sub x. So the derivative of x with respect to time is 9t squared minus 12t minus 12. So that's the expression for velocity along x. So we set this to 0 because the question is when determine when the velocity is 0. So we equate that to 0. And since all coefficients are divisible by 3, dividing by 3 first, so 3t squared minus 4t minus 4 equals 0, which can be factored into, or you may use your calculator if you want, quantity 3t plus 2, then quantity t minus 2. So if for this factor equate to 0, t is negative, so that cannot be. The only possible value of t when the velocity is 0 is t is 2 seconds. Therefore, set this to 0, t is 2 seconds. Then for b, the position when t is 4, so we simply substitute in x in this relation, and we substitute t is 4. So x4 equals 3 times 4 cubed minus 6 times 4 squared minus 12 times 4 plus 5. So x sub 4 is equal to 3 times 4 cubed minus 6 times quantity 4 squared minus 12 times 4 plus 5. And that is equal to 53 meters. So that means the particle when t is 4 is 53 meters to the right of the origin. By the way, when t is 2 seconds, the particle changes direction. So we can view that when we proceed to letter D, because the only way we can imagine or we can clearly compute the total distance traveled is to plot the position of the particles from 0 to 4, or we may extend that to 5. The acceleration when t is 4, the expression for acceleration is ax in particular, and that's the derivative of dx. So ax is the derivative of v sub x with respect to time. And since we have here the expression for vx, the derivative of this is 9 times 2, so 18t minus 12. Then we substitute t is 4. So ax4 is 18 times 4 minus 12, and that is equal to 60 meters per second square. Then d, the total distance traveled after 4 seconds. So that we can compute this conveniently, we have to determine the position of the particle from 0 to 4. We will just extend it to 5 by using the table shown. So all you have to do is when t is 0, x is 5. When t is 1, you just substitute t is 1, but let's tabulate it. These are the results. So when t is 0, x is 5 meters. When t is 1 second, negative 10. When t is 2, negative 19. You just substitute into this equation. When t is 3 seconds, negative 4. When t is 4, 53. We already solved that here. When t is 5, 170, but this is not included. So that we can compute the actual distance traveled. The particle begins at 5 seconds. Then after 1 second, it is now at negative 10. So meaning to say the movement of the particle is to the left. Then when t is 2 seconds, remember when t is 2 seconds, the particle is at rest. So it means that it changes direction. So from negative 10 to negative 19 to the left. So the velocity of the particle from 0 to 2 is to the left. So it is negative. Then when t is 3, it is now going to the right to negative 4. And when t is 4, 53 here. When t is 5, 170. So that's the movement of the particle. And I think if you continue, the particle is now moving to the right when after 2 seconds. So this is the length of the path traced by the particle. So up to 53 only when t is 4. So that means that the total distance traveled from the start up to t is 4 seconds is the length of this path. And the length of that path is 5 plus 19 plus another 19, it went back to the origin, then plus 53. So again, 5 plus 19 plus another 19 plus 53. So that's the actual distance traveled beginning with 0 second up to 4 seconds. So that's 96 meters. Then E, the average velocity during the time interval 1 to 4. So average velocity is change in displacement 1 to 4 divided by change in time. And change in time is just 4 minus 1. So the change in displacement is position of the particle when t is 4 minus position of the particle when t is 1. And that is 53. x4 is 53 minus x1, which is negative 10, then divided by 4 minus 1, which is 3. So 53 minus negative 10 is 63 divided by 3, 21 meters per second. So the average velocity during the time interval 1 to 4 seconds is 21. So x4 is, as I said, is 53, then minus x1, which is negative 10, all over 4 minus 1, which is 3. So that's 21 meters per second. So it's positive, although there's a portion here which is negative, but the distance traveled to the right is more, so that's why the net value is positive. Then letter F, the average speed during the time interval 1 to 4. The average speed, on the other hand, is the actual distance traveled divided by change in time, which is also 3, between 1 and 4. But because when t is 1, the particle is at negative 10, so this is the actual distance traveled by the particle. Beginning with negative 10, going to negative 19, so that's 9 meters. back to the origin another 19, then plus 53. So the actual distance traveled 1 to 4 is 9 plus 19 plus 53. So average speed, remember, is actual distance traveled divided by change in time, which is 4 minus 3. So actual distance traveled between the time interval 1 to 4 is, as I said, when t is 1, the particle was here. Then t is 2 here. So that's 9 meters. Then plus 19 plus 53. So 9 plus 19 plus 53, that's the actual distance traveled by the particle between 1 second and 4 seconds. Divided by 4 minus 1, so that's equal to 27 meters per second. So the average speed also is always positive because that speed is scalar value. Finally, G, the average acceleration during the time interval 1 to 4. Average acceleration is change in velocity, which is divided by change in time, delta V over delta T. And delta V is the velocity when time is 4 minus velocity when time is 1 divided by 4 minus 1, which is always 3. So let's compute first V sub 4. This is the expression for velocity, and V sub 4 is 9 times 4 square minus 12 times 4 minus 12, and that is equal to positive 84 meters per second. V sub 1, because when t is 1, the particle is moving to the left, so we expect it is negative. So 9 times 1 square minus 12 times 1 minus 12, and that is equal to negative 15 meters per second. So we can now compute the average velocity, 84 average acceleration rather, 84 minus negative 15 over 3, and that's 99 over 3, so 33 meters per second. So that's it for this 33 meters per second square. That's it for this video. I hope that you were able to understand the explanations, derivations of the differential equations, and for the situation where acceleration is constant, and the solution to these problems. And I hope that you can find problems and solve it conveniently by yourselves. Bye.